Okay, statistics is basically divided into two different branches: descriptive statistics and inferential statistics. We've kind of mentioned this before. The descriptive statistics consist of methods for organizing and summarizing information. Graphs, charts, tables, for looking at something visual, and even for numbers like mean, median, mode. Those are called measures of central tendency or averages, and measures of variation, standard deviation, variance, and even percentiles. All that's included with descriptive statistics. It's probably what you're most familiar with. I mean, here's an example. This is the breakdown, the class breakdown I had in semesters past. Number of freshmen, sophomore, juniors, and seniors. We see a table on the left, and on the right we see a bar chart. Here's an example of a pie chart, and I'm going to show you how to make all these actually in Excel or in StatCrunch or Minitab, or even the TI can do many of these. I don't think it can do a pie chart without an add-on, but it can do a bar chart. But it doesn't look too good, so we'll stick with this, Excel and Minitab and StatCrunch for descriptive statistics. Now, looking at samples, statistics, and parameters, just some terminology here. The entire group of individuals to be studied is called the population. An individual is a person or object that is a member of that population being studied. And how do we get these individuals? Through taking a sample. So a sample is just a subset from this population. And then there is the individual. Okay? It's a nice little visual of when we're looking at an observation, looking at a person, we got them from a sample which was taken from a population. So a couple terms here. A parameter describes the full population, and a statistic describes the sample. And I'll show you what I mean. Determine whether the underlying value represents a statistic or parameter. So currently 17% of U.S. senators are female. So is that 17% a statistic? Does it describe a sample? Think statistic sample with two S's. Or a parameter? Think a parameter and population, the two P's. Well, it's a parameter, right? 70% of all U.S. senators. I mean, there are only 100 of them, so when there's so few, we often are looking at parameters. But what about this next one? Based on a random sample of Tennessean households, the median income for a family of four was $63,480. I actually pulled this statistic up recently, so it's pretty current as of 2010, 2011. Well, that's a statistic, right? Random sample, looking at a random sample. So inferential statistics consist of methods that take a result from a sample. So we take a sample, and then we extend that to the population. So when we looked at the 63,480, that's reported as the average income. How did they get that? Or the median income? They got that from taking a sample. And we extend that to the population. So we took a sample of 1,000, for instance, and we say, okay, if this 1,000 has an average of 63,480, we can extend that through statistical techniques to everybody. The good thing is we don't have to actually sample the entire state of Tennessee to find out about what the median income is. Through statistical analysis, we can actually just take a much smaller sample. Much more economical, it's not as intrusive, and we actually can sometimes do better than trying to get the whole population. So a primary example is through polls, right? When we look at statistical polls, particularly during election cycles, the presidential election cycles, it'll say, 58% are going to vote for Obama, and 40% for McCain, and then 2% for somebody else. Well, they didn't survey me, but they picked out of the entire nation, they picked maybe 1,000, 2,000 people to do that. And we'll talk more about what needs to be done in order to get a good sample. So here's a famous headline: Dewey defeats Truman for the presidential election. Have you ever heard of President Dewey? Thomas Dewey? I didn't think so. How did they get this headline? Well, in 1948, Gallup took a poll right before the election and found that Truman was only going to get 44.5% of the vote. And he was going to be defeated by the Republican nominee, Thomas E. Dewey. But the statisticians had predicted incorrectly, obviously. Truman won with more than 49% of the vote, and with it he got the presidency. So the Gallup organization has since, this has been over 60 years ago, has since modified many of its procedures and actually correctly predicted the winner ever since. How do you determine which one you are looking at, inferential or descriptive? So, examine and explore for intrinsic value, descriptive. If we're drawing conclusions about an entire population based on a sample, it's inferential. So if the intent of the study is to examine and explore information obtained for its own intrinsic interest, the study is descriptive. But if the information obtained from a sample population and the intent of the study is to use information to draw conclusions about that population, the study is inferential. A descriptive study may be performed on a sample as well as on a population, but only when an inference is made about the population based on that sample does the study really become inferential. So examples, inferential or descriptive. So the examples that follow tell whether they're inferential or descriptive statistics were used. So in the year 2010, 148 million Americans will be enrolled in an HMO. Well, that's inferential. I mean, right? They couldn't possibly have surveyed the entire nation for that. Drinking decaffeinated coffee can raise cholesterol levels by 7%. What do you think? Inferential, right? I mean, how did they determine this? They did a study where they had 100, 200 people volunteered, randomly sampled to drink decaf coffee, and then another one drank something else that wasn't decaf coffee, and they realized that it raised cholesterol by 7%. Enrollment at MTSU in fall 2006 was 22,863. That's descriptive, right? I mean, we could actually look at the entire population of MTSU. We can look at that data very easily. Now, what they said in fall 2011 or fall 2012, it's projected to be, 26,000 or something like that, 27,000. Well, that would be inferential, right? They would be based it on some sort of model that's predicting something. And here are the answers here. I forgot I had those out. Okay. The A.C. Nielsen Company collects and publishes information on the TV viewing habits of Americans. Data from a sample of Americans yielded the following estimates of average TV viewing time per week for all Americans. What do we think? Inferential or descriptive? Does Nielsen have something on you? Probably not. A little side note, when I was in college, I actually had I was the one home in Murfreesboro that had a Nielsen box on my TV set. So it didn't matter what anybody else watched, it's what I watched. I didn't watch a lot of TV, so they didn't really get a lot from me. But anyway, this is inferential, right? So they just take a sample of Americans' viewing habits. A Newsweek poll of a sample of 100 of Americans revealed that 84% of those surveyed would choose organically grown produce over produce grown using chemical fertilizers, pesticides, and herbicides. Okay, is this inferential or descriptive? What do you think? Well, inferential, right? A sample of those surveyed, right? Actually, I didn't read that right? It actually says 84% of those surveyed. So that's actually descriptive. They're describing the percentage of those surveyed. They're not trying to extrapolate that to everybody. But what about Part B? Based on the same information, what if the statement had been 84% of Americans would choose organically grown produce over the produce being used using chemical fertilizers, pesticides, and herbicides? That's the one that would be inferential. So we have to read those carefully. Of those surveyed, even had that underlined. Okay, I believe this is the last example. In a press release dated October 22nd, 2002, ABCNews.com reported that 73% of Americans favor a law that would require every gun sold in the U.S. to be test-fired first so that law enforcement would have its fingerprint in case it were ever used in a crime. Do you think that statement is inferential or descriptive? So this is going to be a inferential statement, right? Because it says 73% of Americans. So again, whenever they say 73% of a huge population, it'll almost always be an inferential statement. So they actually just took a sample of that. In Part B, actually, ABC conducted a telephone survey, random sample of 1,032 adults, determined 73% of them favored a law that would require every gun sold in the U.S. to be test fired first. How would you rephrase a statement in the press release to make it clear that it's a descriptive statement? So you could say it's descriptive 73% of the surveyed favor a law, yada, yada, yada. And an inferential statement, 73% of Americans, you could say about the survey, they were 1,032 adults, and we can infer from that to the population.